Hello and welcome to this presentation, Demystifying Fiber Optics with the Fiber Wizards. The purpose of this presentation is to demystify basic concepts of fiber optics and hopefully inspire you to join us in our mission to promote this technology around the world. During this presentation, we will aim to achieve the following objectives. Number 1, to answer what fiber optics are and how they work. Number 2, to discuss critical fiber-related safety practices. And number 3, to explore basic processes related to the fiber optic installation. Before proceeding, always remember to inform yourself of local regulations and requirements related to safety for the fiber optic work that you're planning to perform. Without further delay, get ready and let's go. Optical fibers are high-purity strands of glass used for transmitting light signals for telecommunications. These strands are very effective at carrying signals over long distances with very little loss of quality. Because light signals travel at the speed of light, these can transmit huge amounts of data with unmatched speeds. To put it in perspective, you could probably stream Netflix's entire movie library around the world in just a few seconds using just a couple of fiber strands. One of the main advantages of using optical fibers is that these are made primarily of silica, which is among the most abundant elements on Earth. Another advantage of using fiber optics is that these are immune to electromagnetic interference, as these are made of non-conductive materials. Electromagnetic interference is everywhere, even in the atmosphere, so it can create signal noise and affect both wireless and copper-based communications. Because fibers can carry much more information than traditional copper cables and are literally a small fraction of the size and weight, logistics are less expensive and installation is faster and more efficient. The global internet network is also possible thanks to the optical fibers that are used in submarine cables that circle the world, connecting all continents. All these advantages make fiber optics the fastest, most reliable, and preferred option for telecommunications service providers around the world. So how are fiber optics manufactured? As we mentioned a moment ago, the main raw material used for fiber manufacturing is silica, which is melted into ultra-pure glass tubes that are then infused with other chemicals in a process called vapor deposition. This process results in the creation of preforms, which are then transferred into drawing towers to be consolidated, melted, and stretched into very thin strands, and then coated and spooled into reels. Let me show you something. Let's strip this fiber. Do you see it here? There it is. This is the fiber that we use for connecting the whole world. Okay, so let's talk a little bit about the basics of fiber optics. Optical fibers are composed of two main parts, the core and the cladding. As fibers are very thin, these are prone to damage caused by scratches and bending. For this reason, these are protected with an acrylate layer known as coating. It is important to understand that though the core and the cladding of the fibers are distinct areas of the same fiber, these are parts of the same glass and cannot be separated. What makes the core different from the cladding is that during the manufacturing process, these are infused with chemicals to change the transmissive properties of the core, to create an effect known total internal reflection and make long-distance transmission of light possible with fiber optics. We'll talk a little bit more about this in the next video of this series. To help you better visualize this concept, I will take a fiber and inject light into it using a laser. As you can see here, there is some light flashing in the central region of the fiber, which is the dark circle that you see on the phone. The lit area that we see here is the core of the fiber, through which most of the light is transmitted when optical signals travel through them. Let's take a look at this cross-section diagram of a fiber. As we can see here, there are different numerical values shown for the core. These point to different fiber types, generally classified as either single-mode or multi-mode. Multi-mode fibers typically have core diameter sizes of either 50 or 62.5 microns, and single-mode fibers of 9 microns. Even with smaller cores, single-mode fibers have higher information transmission capacity than multi-mode fibers. Multi-mode fibers are generally used for indoor installations. On the other hand, single-mode fibers are mostly used for outdoor applications or indoor applications that require a high-speed data transmission. In most fibers, whether single mode or multi-mode, the cladding's diameter size is of 125 microns. Okay, so let's see how we're doing so far. If you're watching this as part of a Fiber Wizards training program, please take a couple of minutes to complete the corresponding quiz. Otherwise, I'll see you shortly on the next section. Please stay close and we'll see you soon.